Somewhere on Earth right now, one town gets more rain in a single year than most countries see in a decade. Now imagine that never stopped. Not for a week, not for a season, for all 365 days. Could the planet survive a year of non-stop rain? No sun breaks, no dry mornings. Just rain, hour after hour, month after month. Let's set the rules first. This isn't a light drizzle. This is real, steady, soaking rain, falling somewhere on every square mile of the planet, every single day, for one full year. No region gets a break. No season resets the clock. No dry spell shows up to save anyone. We're not asking if that's physically possible. We're asking what actually happens to the ground, the oceans, the crops, and us, if it does. Let's find out. Day one looks almost peaceful. Streets shine, gardens perk up. Farmers, for a moment, feel relieved after a dry spring. But the ground is already doing math against you. Soil can only hold so much water before it's full, the same way a sponge stops soaking once it's saturated. Once that happens, rain stops sinking in. It starts running off instead. And that's where week one quietly turns dangerous. By the end of the first week, low-lying streets are pooling water that has nowhere left to go. Storm drains, built for occasional downpours, choke under constant flow. Rivers that normally rise and fall with the weather start rising and simply staying up. Reservoirs designed to buffer a wet month suddenly face a wet year, with no dry stretch to draw them back down. This is the first stage of our escalation, saturation. And once soil is saturated, everything sitting on top of it becomes unstable. That instability turns deadly fast. The United States Geological Survey has spent decades studying what triggers landslides, and their research is blunt about the mechanism. It's rarely the storm itself that causes the collapse. It's the water already sitting inside the soil from the rain before it. Add non-stop rain on top of ground that never gets a chance to drain, and hillsides that stood firm for centuries start to slide. Roads crack along their edges, trees lean, then tilt, then fall. Whole slopes give way in minutes, burying anything downhill without warning. Now push forward to month 2. This is stage 2, infrastructure failure. Basements flood and stay flooded, because there's no dry spell left to pump them out. Roads crumble as water works into hairline cracks and pries pavement apart from underneath. Freeze or no freeze. Bridges, engineered to handle rivers at their highest seasonal peak, now face rivers that never drop back down to a manageable level. Underground, water tables rise until they meet the surface, turning entire neighborhoods into standing lakes, with rooftops poking out like tiny islands. Here's the part most people don't expect. Farms fail long before famine even becomes a headline. Waterlogged soil starves plant roots of oxygen, and most staple crops, wheat, corn, and flooded rice paddies alike, simply drown within days of truly constant saturation. Global agriculture depends on predictable dry windows for planting, growing, and harvesting. Take those windows away for 12 straight months, and the food system doesn't just slow down. It stalls out completely, region by region, harvest by harvest. There's a quieter danger too, one that doesn't show up in flood footage. Constant dampness is a perfect breeding ground for mold, and mold spreading unchecked through walls, ceilings, and ventilation systems triggers respiratory problems on a massive scale. Standing water everywhere means more mosquitoes, more stagnant pools, and a sharp rise in waterborne and insect-borne illness. Hospitals, already stretched thin by flooded roads keeping ambulances from reaching patients, would face a steady climb in cases, with none of the usual dry weeks to let outbreaks settle down. And there's a psychological cost, too. Researchers who study seasonal weather patterns consistently link prolonged gray, sunless stretches to rising rates of low mood and fatigue. 12 straight months without real sunlight wouldn't just strain infrastructure, it would strain people. Wildlife wouldn't sit still through any of this either. Animals that depend on dry burrows would find them flooded out within weeks, forcing sudden migrations into already crowded, shrinking dry ground. Birds that nest on the earth would lose entire breeding seasons in a single year. Insect populations, especially pollinators, would crash under relentless wet conditions, and that collapse would ripple straight back into the same waterlogged farms already struggling to produce food. Nature doesn't pause during a crisis like this. It scrambles, adapts, or disappears, all at the same time. all under the same endless gray sky. So how bad does this actually get? Let's move to stage 3, the long collapse. By month 6, transportation networks are crippled almost everywhere. Airports can handle rain, sure, but not rain combined with flooded runways, washed-out access roads, and grounded ground crews. Shipping ports struggle as flooding disrupts loading equipment, cargo yards, and the access channels ships depend on. Electric grids, especially anything routed underground or through low-lying substations, face repeated, rolling outages that stop being repaired and start being permanent. And here's a sobering thought. None of this needs a single hurricane or one record-breaking storm. It just needs rain that never takes a single day off. What about the water itself? Where does an entire year of non-stop, planet-wide rainfall actually go? Some of it runs straight into rivers, swelling them past historic flood stages we've only ever seen briefly during major storms. Some of it sinks into aquifers, which sounds helpful, until you remember that overloaded aquifers push groundwater back up into basements and building foundations from below. And a significant portion runs straight to the ocean, carrying with it loosened sediment, fertilizer runoff, and debris that reshapes coastlines and smothers marine ecosystems that depend on clearer, calmer water to function. You might be wondering if anything like this has ever actually happened, even briefly, anywhere on the planet. And the answer is yes. We have a real place that gets shockingly close, every single year, right now. Mawsynram, a small village in northeast India, holds the record for the highest average annual rainfall on Earth, receiving rain on the overwhelming majority of days each year, month after month, almost without pause. The village has adapted with homes built for constant dampness, drainage systems woven into daily life, and communities that have quietly learned to function around water that simply never fully stops falling. It's the closest living preview we have of what a non-stop rain world might actually demand from the people living inside it. But there's an even bigger, older answer buried in the rocks themselves, and it's where the real science gets fascinating. Around 232 million years ago, Earth experienced something scientists now call the Carnian pluvial episode, a period when global rainfall dramatically intensified for roughly 1 to 2 million years. Researchers Jacopo Dal Corso and Michael Benton, publishing their findings in the journal Science Advances, traced this ancient wet phase through chemical signatures locked inside rock layers pulled from sites across the globe. Their evidence pointed to massive volcanic activity pumping enormous volumes of carbon dioxide into the atmosphere, supercharging the water cycle and triggering an extended, planet-scale period of intense, near-constant rain. Here's the twist. That ancient mega-rain event didn't just flood the planet and move on. It quietly reshaped which animals got to survive it. Many reptile lineages struggled or vanished entirely under the pressure of that shifting, waterlogged world. But dinosaurs, still a small, minor group before this event, came out the other side thriving in a way nobody would have predicted. Dal Corso and Benton's research suggests the Carnian pluvial episode may have cleared ecological space that let dinosaurs expand, diversify, and eventually dominate the planet for the next 165 million years. A year of non-stop rain on our sped-up, human timescale wouldn't unfold over 1 million slow years the way it did back then. But it gives us a real, evidence-based preview of the underlying pattern. Intense, sustained rain doesn't just cause damage in the moment. It rewrites, over time, who gets to keep surviving and who quietly doesn't. So here's our answer. Grounded in real geology and real hydrology, not guesswork or disaster movie exaggeration. A full year of non-stop rain wouldn't drown the entire planet outright. Oceans wouldn't rise up and swallow whole continents in 12 months. But it would systematically dismantle the everyday systems we depend on to live comfortably on land. Farms would fail long before famine made international headlines. Roads, bridges, and power grids would crumble under stress they were never engineered to withstand for that long. Landslides would reshape hillsides we've always assumed were permanent fixtures of the landscape. And low-lying cities, the ones already sitting closest to sea level, would face the harshest reckoning of all, some potentially uninhabitable, well before the 12 months were even over. Here's the modern mirror, and it's worth sitting with for a moment. We don't need a full year of literal non-stop rain to see fragments of this exact future play out already. Climate researchers have documented a clear global trend toward more intense, more concentrated rainfall events compressed into shorter windows, followed by longer, drier stretches in between. That's not identical to the 12-month disaster we just walked through, but it stresses the exact same weak points: saturated soil, overwhelmed drains, and infrastructure built for a climate that no longer quite matches the one we're actually living in today. Every flooded basement on the evening news, every landslide warning issued after days of rain, every drained reservoir followed by a sudden flash flood is a small, real echo of the exact mechanism we just explored at full, planetary scale. And it wouldn't hit everyone equally. Coastal megacities already fighting rising seas would face flooding from above and below at the same time. Overwhelming pumps and levees designed with a much smaller margin of error. Inland farming regions, the ones that feed billions of people every single year, would see entire growing seasons wiped out back to back, with no dry window to replant before the next downpour arrived. Wealthier cities might hold the line longer, propped up by better drainage and emergency funding, but even they would eventually run out of places to put the water. Poorer regions, often built on the exact floodplains that flood first, would absorb the earliest and harshest impact long before the rest of the world even finished adjusting its forecasts. Which brings us back to where we started. Somewhere on Earth, rain never really stops. Not fully. And that one small village has spent generations quietly adapting to nearly year-round downpours as an ordinary fact of life. Multiply that by the entire planet. Sustain it for 12 full months without a single true dry spell, and you don't get a sudden apocalypse of rising oceans overnight. You get something quieter, and in some ways far more unsettling. A slow, grinding collapse of the systems, farms, roads, power grids, foundations, that we've built while quietly assuming the sky would eventually, always, give us a break. So the next time it rains for a few days straight and you feel that small flicker of frustration, remember, that's a preview, not the whole story. And the whole story, the one written in ancient rock layers and modern flood maps alike, is still being figured out, one storm, one soaked hillside, one saturated field at a time.